these were incorrect last year. That doesn't mean that they're necessarily difficult, it just means that people got them wrong. And notice what I circled in number 2. A lot of you are doing this. You are finding angle P. Is that what it says?
No.
It says find tangent. What did we write down at the beginning of our trigonometric notes? What are sine, cosine, and tangent? They're fractions. This is asking for a fraction.
So tan angle
Where's P? There's
over
P.
A.
I need O, I need A, I need 3 over 4. Done. Yes, you don't want to make a mistake on an SOL test or a test just because you're finding something that's not being asked for.
Because like, you have to find the tangent of the angle.
We did. It's 3/4. I'm not asking you for the angle. I don't care what the angle is, I just want to know what the tangent is. The tangent is a fraction. There's the fraction. Now, come down to number 3. Number 3 is asking for an angle. Right in that spot. Since it's looking for an angle, this is where we want to use inverse. I think last year, some people got confused just because it was a decimal being handed to you. 5, 6, 7. It doesn't matter if I put a fraction in there. Can a fraction be written as a decimal?
Yeah, maybe.
What are we getting for number 3?
What Brandon said.
35 degrees? Look at the difference. One is looking for an angle, the other one's looking for an actual tangent. So if it's just asking for sine, cosine, or tangent, it's just asking for an angle. By it, I mean the quiz or test that you're taking.
So, is this going to be like the test, or is this going to be like the SOL?
Both. Some of the test isn't going to show up on the SOL because you're in a pre-AP course, so you're expected to know a few more things. Like,
Are we taking a different SOL than the regular geometry?
nope, same SOL. Fatima, you were asking about those 2 questions at the end of that one sheet. This helps explain that. Underline, circle, angle of elevation. That's a very specific term. It actually means something. When you think elevation, you probably think higher up. But in reality, where it appears in the right triangle is at the bottom.
What?
That is considered the angle of elevation.
Wouldn't that make sense?
Because you're looking up.
You're looking up. Here's a tree that's 43 feet. Where's the shadow?
Behind it.
People last year were putting shadows up here. Shadow is down here, I hope.
Why can't it be behind it?
Same triangle. And that's our variable. If all of this extraneous information is clouding your judgment, then redraw it without all the details. If you do that, I'm looking at opposite and adjacent. That's tangent. I'm looking for a side. Some people like to put in the decimal in that spot. I prefer to just let the calculator handle it. In any case, what do I have to do to get rid of whatever's in front of that x? Divide. So if you've got a decimal there, divide by the decimal. If you're just letting the calculator do the work, you're going to be doing 43 divided by tangent 57. And that is approximately 27.92 feet, because we were going for, I believe, 100th place? Was it feet or meters?
7.92.
100th of a foot, so 27.92.
The 100th of feet.
So the mistakes made last year, people put the angle of elevation up here instead of down there. Put a dotted line right up here. What kind of letter shape am I creating now?
D or an N or
Z shape? What does that remind you of back in chapter 3?
Alternate.
Didn't we say that alternate interior were equal?
Oh, yes.
Sometimes you're given that angle. That angle up here is called the angle of depression. Because you're looking down. Either way, it's the same angle. If you're given this on the outside, bring it into the inside. If they want to know the outside, take it from here and put it on the outside. It's an alternate interior pair. That should help you do those two questions. If we don't get it. Turn your paper over. We are not doing number 5. We don't need to do that.
explain.
Yeah, we went to the.
Let's jump down to number 6.
And today we work on do it in a signature.
I am looking for with one squiggle or two? Two is approximate. You've never seen approximate?
No, she didn't believe me.
Okay.
Question.
Yes.
Is there proofs for this?
Proofs for this. No, not this chapter. Chapter 8.
No, it doesn't. Approximately.
Wait, hold your questions till after. For finding y, it looks like one figure, but how many triangles do you actually have? How many right triangles do we have? Right triangles. 2. We have a third triangle here, but we're not interested in it because it's not a right triangle. Do both of them have 200 at the bottom?
Yes, sir.
If I put 67 over here, let's call this side W. And if I put 36 here, I'm going to call this side X. So from here to here is which variable?
X.
From here to here is which variable? How can I find Y?
X minus W.
Correct? X minus W. If I know this and subtract this, will I get that?
Yes.
Well, you've got 2 trigonometric problems that will get you your X and your W. Go ahead and do that right now. Well, you got to find X and W using trig. Use your sine, cosine, and tangent twice. Even though it's one picture, you're actually doing 2 separate problems. Find X, find W, subtract. Because all of your answers are whole numbers, I would just round to the nearest whole number before I subtract. And according to the setup, does it look like I have the same pieces?
Yes, sir.
So you're probably going to use the same exact trig function, whatever it is.
That's and
start working my way through one of them. This looks to me like an OA situation that's Is everybody using tangent? Since the setup is the same in both triangles, you're going to use tangents again, or twice. It looks like the variable always ends up on the bottom, which means you end up doing a little bit of division. Since that one looks exactly like this one, except for 36 degrees instead of 67. I believe that turns out to be that. Or close to. That's great. I've got X, I've got W. What should I do with these to find Y?
Put that like that.
275 plus 85 divided by 2.
If you put it all back into the original, this is 275, this is 85, and this is 190. Does it look like it's drawn to scale?
No.
That's 190, and that's 85. So it's not drawn to scale, it doesn't matter. If you actually drew it, it would look like
I told you.
more like this, 67, 36. This would be longer than this piece, but it's never drawn to scale, unless you're told it is. Any questions on that one? You just have two separate problems that you have to do to figure out two separate pieces, then do a little bit of subtraction. Number 7, take out your formula sheet.
Wait, did I already lose it? Oh, never mind. I thought I already lost it. Whatever you want to put it.
No, don't get it. Don't get it. No.